good. So my name's Robbins, and I'm doing the group lead for the Clapeyron experiment next week. So the objectives of this experiment, understanding what vapor pressure is, and I'll go over that on the next slide. How this vapor pressure is affected by changing temperatures and pressures inside of a vacuum, and then using some steam tables to verify that the sample calculations line up with what's actually happening. So a little background on the Clapeyron equation. So like I said, the whole point of this is to determine the heat of vaporization, which is that HFG term, and that heat of vaporization is the amount of heat it takes to vaporize 1 gram of any liquid. So that's the Clapeyron equation right there. It's changing temperature or changing pressure with respect to temperature, and you can see what each one of those is. And then, so summing in with the ideal gas is actually how I'm going to do some of these sample calculations. So, and that's how it's done in the experiment, where the idea of this equation is to take things that are easy to measure, like temperature and pressure, and then get that heat of vaporization. So the way the sample calcs will work, and I may come back to this slide, I'll rearrange for that H value with the Psat and the dPsat over dt. And yeah, so some of the common real world applications, it's used to determine the moisture in the air and some global warming aspects from what I was reading, and calculating that heat of phase change. So the components of the experiment, you have that 100 or 1,000 milliliter flask with a rubber stopper to seal it at the top, a hot plate heater to boil it, a thermocouple to measure those temperatures, a pressure transducer, a mechanical pressure gauge, an air bleed valve, a vacuum control valve, and a centrifugal pump, a water reservoir, and then the control system that will be used to log that data. I'll kind of run through, you'll see how this all connects in the experimental setup and procedure. So this is just a quick setup for the data acquisition. You're just verifying that things are working at the beginning, really. I don't think it's too important that I go through every one of these steps. It's kind of going to get monotonous. So the experimental procedure, setup and prep. So said the instructor is going to tell you whether boiling beads are needed or not, and you're going to fill that 1,000 milliliter flask with 2 inches of water and place it on the hot plate with the thermocouple about 0.75 inches under the water. Close the vacuum control valve and open the air bleed valve, turn the pump on, verify that the air is being drawn in, and then leak test the system, which the manual goes into more detail on how to leak test it. The actual experiment, so the whole idea of this experiment is to see how changing pressure affects the boiling temperature of water. So you're going to turn the vacuum on, or that water pump, and then you're going to open the air bleed valve, and that's going to pull a vacuum onto your beaker. And then you're going to boil the water, and you're going to begin logging data after it begins. Once that happens, you close off that vacuum valve and slowly let the pressure rise, and you'll see a trend in how pressure rising affects your temperature. So to be safe, you need to avoid pressure buildup and open the air bleed valve when the pressure is approaching atmospheric, and then stop taking data, turn hot plate off, and let everything cool off. Shut down, close the vacuum control valve and open the air bleed, turn off the pump, turn off the plate, and disconnect the power supplies, and then make sure everything's clean. So predict the results. This is using a steam table going from 0 to 200. So I want to make sure I captured that boiling point of water where it usually is at boiling point of water is 212. Yeah, Fahrenheit, around 100 degrees Celsius. So curve fitting that, you can take the derivative of the curve fit and get that dPsat over dt. And that's what's used in this to calculate, how I mentioned, rearranging that value for HFG. And these were just 3 arbitrary points that I used and calculated these These were the calculated values, and these were the tabulated values. So pretty accurate except for that last one, but yeah. So some uncertainties that might come about, there's always uncertainties in the measurement, the instruments used for measuring, and that thermocouple and the analog pressure transducer, and then safety. We're going to be working around a hot boiling water on that hot plate, so just got to be careful around that, and then just general lab safety. So, any questions?
Question.